today's class, I'll be talking about whether the collision is an elastic collision or an inelastic collision. That's what our focus will be on. In the last class, we talked about the momentum and the conservation of momentum in one dimension. So we end up writing down the equation P initial should be equal to P final. That's the equation we wrote. And we also expanded this. We wrote that M1 V1 plus M2 V2 equal to M1 V1 plus M2 V2. And this was initial, this is final, and the final down here. That's what we wrote down for the conservation of momentum equation. Mark my words, this is the conservation of momentum equation. Now we will try and find out whether the collision is elastic or inelastic. Elastic or inelastic. To find out whether the collision is elastic or inelastic, we will use the equation, kinetic energy equation. So kinetic energy is equal to, what is the formula for kinetic energy? That is equal to half mv square. That's the formula. Now, if the kinetic energy of the system is conserved, means kinetic energy of the system, initial kinetic energy is equal to kinetic energy final, then the collision is elastic. If they are not equal, then the collision is inelastic. So how we can elaborate onto it? So it will be half mv1 square plus, I'll write it m1v1, and half m2v2 square plus, not plus, it will be equal to, I'm assuming that there are two bodies in a system. One half m1 v1 square plus 1 half m2 v2 square, and this is final, this is final, and this is initial. This one is, I'll remove the bracket and put an initial to this one too. So this equation again will only be used to find out whether the collision is elastic or inelastic, or if you are given the collision is elastic, then you can find the missing parameter by using this equation. But this equation will only hold good for the elastic collisions, whereas this equation will hold good to find out velocity or mass at any time. Whether the collision is elastic or inelastic, you can use this equation. So hopefully you are clear about when to use which equation. Now let's go to this question given to us down here. In this question, 0.160 kg billiard ball traveling at 0.500 meters per second north strikes another stationary ball whose mass is given to us, and then rebounds at uh, a certain velocity. The snooker ball moves at 0.650 to the north. Ignore the possible rotational friction. Determine whether the collision is elastic or not. So if the collision is elastic or not, we wanted to prove that. What do we need to do? We need to use the equation which we just learned for the elastic collisions. So I'll write down the equation: half m1 v1 square plus half m2 v2 square equal to half m1 v1 square plus half m2 v2 square. This is the equation I'm going to use. So if the sum of the initial kinetic energy for both the bodies is equal to the sum of final kinetic energy of the bodies after collision, then it's elastic. If they're not equal, then it is not an elastic collision. So the initial mass is given to me for the billiard ball, which is 0.160, and the initial velocity is also given to me, which is 0.500. Notice in this case, I don't need to worry about the north, south, east, positive, because when we talk about the energy, we do not worry about the direction of the energy. So this is square plus half times the second ball is 0.180, and what is the velocity of the second ball? Which this is the velocity, 0.20230. This is, well, no, let me read this question one more time. This billiard ball traveling at this strikes at stationary this ball and rebounds at this. So this is not the velocity of the second ball. So this is actually the velocity of the first ball. So the snooker ball moves off at this velocity, strikes a stationary. So it is a stationary ball, snooker ball is. So 0 square, which is equal to half times, if I elaborate onto this, let me make some space down here, and half times 0.160 multiplied with the velocity. It rebounds at what velocity? It rebounds at 0.0230, 0.0230 square, and plus half times, oops, let me make some space. I didn't realize it's gonna be that much of an equation. So it's half times 0.180 times 0.465 square. Again, we don't need to bother about the direction in this case. Whenever we are talking about the energy, we will not bother about the direction. And this becomes 0. And if I do this calculation, this comes out to be 0.0200. And the units of energy is joules. So I'll keep it joules. Then if I do this calculation, this will come out to be 0.0195 joules. So are they equal? They're pretty much close, but they're not exactly equal. That's why I've kept the answer up to the 4 decimal places, because I wanted to find out actually they are exactly precise or not, means they are exactly same or not. So they are not in this case. So I will call it as the collision is inelastic. Inelastic. Some of the energy got lost because these two are not the same. So hopefully you were able to understand how to simplify this kind of a question. Now, with this, I'm going to take another question. In this question, we are given some different circumstances. A 0.0149 kg bullet from a pistol strikes a 2 kg ballistic pendulum. Upon impact, the pendulum swings forward and rises to a height of 0.219 meter. What is the velocity of the bullet immediately before the collision or before impact? So I'll draw the diagram for this. If this is the pendulum given to me, on this pendulum, the bullet strikes, this is the bullet, and once this bullet strikes this pendulum, it gets embedded into the pendulum, and then pendulum, because it is hinged from the top, so it moves in the upward direction like this. That's how the pendulum moves. Okay, let me redraw it. So it moves something like this. This was the initial position of the pendulum. Let me change the color for the initial position. That's the initial position of the pendulum. Obviously, it cannot move in the forward direction, so it moved vertically upward. That's what the situation given to me. And how much is the height it gains? 0.219 meters. That's the height it gains. And then, yeah, that's what's given to me. The mass of the bullet is 0.0149 kg, and then it strikes the 2 kg of the ballistic pendulum. This is 2 kg, which is given to me, this pendulum mass. And forward direction rises to this. What is the velocity before its impact? We wanted to find the uh, velocity of the bullet before impact, or before collision, we can call it as. So I'll write down the equation: m1v1 plus m2v2 equal to m1v1 plus m2v2. So notice in this question, it is not talking about any kind of a uh, any type of uh, elastic collision or inelastic collision. So we won't assume that the collision is elastic. So we're not going to use the conservation of uh, we won't use the conservation of kinetic energy equation. So thus I'll use the conservation of momentum equation. Now m1 v1 plus m2 v2. Uh, what is given? Mass of the bullet. I'll call it as this for the bullet and this for the pendulum. So mass of the bullet is given to me, which is 0.0149 kg, and v1, this is what we wanted to find out, initial velocity, and plus mass of the pendulum. Mass of the pendulum is given to me, which is 2 kgs, multiplied by initial velocity of the pendulum is 0 because it's stationary before the bullet strikes it. And then m2 v2, m1 v1 plus m2 v2. Now the bullet, once it strikes the pendulum, this bullet, once strikes the pendulum, gets embedded into the pendulum. I guess you will agree with this thing that this is going to get embedded and then both will move at the same velocity. So I can call it as m1 plus m2 because both becomes one system times v final. Now this thing will be 0, but now I'm stuck here. I have the mass down here, which is 0.0149 plus 2 kgs, and v final is not given to me. And I'm going to solve this because this is what I wanted to solve it for, 0.0149 v initial. So to solve for v initial, I need to first of all find the v final. So what I'm going to do is I'm going to look back into the question and see what other information is given to me. So if I see it's given to me, the pendulum rises to a height of 0.219 meter. So if the pendulum height is given to me, it means potential energy of the pendulum is, I can figure out because the mass is given to me, mgh. Mass is 2 kg, g value is 9.81, and height it attains is 0.219. So that's going to give me the potential energy. Now, conservation of energy, if you can recall the conservation of energy, it says the energy can only be converted from one form to another. So whatever the kinetic energy of the pendulum was down here, once the bullet got embedded into it, that got converted into the potential energy up here. So I can call it as potential energy equal to kinetic energy. That's the equation I'm gonna use down here. And then kinetic energy is equal to half mv square, and potential energy is mgh. Because we are talking about the bullet is embedded into the pendulum, both masses are same. So both masses are same. I can cancel this, and g value is 9.81 times height, which is 0.219, and equal to half times v square. From here I can find the velocity. 2 times this goes on the other side, 9.81 times 0.219, and then this square goes on the other side, becomes square root, and then you will find the velocity from here. That velocity comes out to be 2.073 meters per second. That's the velocity. And this is the final velocity after the impact, because this everything we are talking about here is the velocity after the impact. So we've been able to find out the final velocity. Now once we have the final velocity, I can use that final velocity down here and can simplify for the initial velocity. So 0.0149 plus 2.000 multiplied by 2.073, and then this is 0.0149 V initial, dividing both sides by 0.149 cancels out 0.0149, and if you're going to do the calculation, you will find it comes out to be approximately 278 point something, but I'm rounding up the answer to 280 meters per second. That's the initial velocity you will get, and this number comes out to be a positive, so this is a forward velocity, and the bullet was initially moving in the forward direction. So hopefully you get an idea about how to approach these questions. Again, one more time, if you are given if you are asked to find out or given where the collision is elastic, then only you're going to use this equation. Otherwise, stick to the other equation, the conservation of momentum equation. You can use it anywhere. So yeah, that's about it. And if you like the lecture, do think of subscribing it. That'll be great. And I'll see you in another class.